Welcome back to this video. In this video, we're going to solve this coding interview question power set. In this problem, given a string S, find all the possible subsequences of the string in lexicographically sorted order. For examples, if we are given ABC, we have to return A, AB, ABC, AC, B, BC, C. These are the subsequences. We have to return the subsequences in lexicographically sorted order. The power set of ABC, the total number of set we have in the power set. So for this input ABC, we have to return this list of subsequences. For examples, if we are given AA, we have to return AA, these subsequences. Now let's see how to solve this problem. We know that we can generate power set using backtracking algorithm. But in this video, we're going to generate power set using bit manipulation. Let's see how to solve this problem using bit manipulation. For sake of understanding, let's assume we are given this string A, B, C. The index of A is 0, index of B is 1, index of C is 2. Now we're going to create a binary number. We will map C with digit 1, B with digit 1, A with digit 1. In binary representation, we know that for integer number in binary representation, we have 32 bits. We are dealing with the 3 bits. This is the right 3 bits. 3 bits from the right. We have a bit on the left, so we should have total of 32 bits. We're just dealing with these 3 bits on the right. We have some more bits on the left. Just for demonstration purposes, I'm not going to show you all the bits on the left. So we have here 1, here we have 1, we have here 1. We know that in binary representation we have 1 and 0. We have 1 and 0. At this position we have 1. It means we will select. We're going to select this C. Here we have 1. That means we're going to select B. At this position we have 1. That means we're going to select this character. So from this number, what we will get? We will get, if we select this A, then this B, then this C. So we get ABC. Then the next possible binary number is 0, 0, 1. So we'll select just C. We're not going to select B and A because we have the value at the corresponding position 0. So we're going to select just C. Then we might have something like this 0, 1, 0. We're going to select just B. Then we may have this binary number 1, 0, 0. We're going to select just this character A. Then we may have something like this 0, 1, 1. Here we're going to select B and C. So B, C. We may have something like this 1, 1, 0. We're going to select here A and B. Then we may have something like this 1, 0, 1. So here we're going to select AC. So we find out the power set. We find out the power set. We are not considering empty set in the power set. So we find out the power set. ABC, CB, ABC, AB, AC. Now let's talk about how to find out this number. Let's find out this number. How to find out this number? So let's write out the binary equivalent of the decimal equivalent of this binary. So let's find out. If we write out here the binary number, we calculate first. We have here 1, then 2, 4. So 4 plus 2 plus 1. We're going to select 4, 2, and 1. So what we get? 7. Here we get just 1. This is the decimal equivalent. Here we will get 2. Here we get 4. Here we get 3. Here we get 6, and here we get 5. If you clearly observed, we get number from 1 to 7. 1 to 7. Now if we have this A, B, C, D, if we have A, B, C, D, we will have first this, then we will have the combination of binary numbers with these 5 positions. If we try to find out that, we will have number from 1 to 15. This is 15. Let's find out. 1 2 3 1 2 4 8 8 8 plus 2 10 plus 1 5 4 5 so 8 plus 2 10 10 plus 1 11 11 plus 4 equals to 15. So we will have number from 1 to 15. We find out a pattern. If we multiply 1 by 2 to the power the length of the string 1 2 3 3. So here what we get 8, and here 1 times 2 to the power the length of this string is 4. So what we get 16. We see that we find out 1 slightly greater than. We see that this 8 is greater than 7. Just this is greater than by 1, and also this 16. We see that this is 16. So one more than the actual maximum number we may have in our range from 1 to 7, and here we get 16, and the representation of this maximum number is 15. So if we just subtract 1, then what we will get 15, and here what we will get if we subtract just 1, we get 7. So we can find out that easily. If we say the maximum number, this is the maximum number for this given string. This is the maximum number. We can find out that using this 1 left shift n. N is the length. So we are finding out actually this. We are multiplying 1 by 1. We are multiplying 1 by 2 3 times. Left shifting, if we left shift 1 by 1 position, then that means we're multiplying the 1 by 2, and this is equivalent to 1 times 2 to the power 3, and for this number it is equivalent to 1 times 2 to the power 4. Okay, so if we just subtract here, if we just subtract 1, what we get the maximum number. Now if we run a loop for I equals to 1, I less than equals to max, then I plus, then what we will get? First we'll get 1. For 1 we will get a C. We will extract the character from our string. Then we will get 2. For 2 we will extract B. For 3 we will extract B, C. For 4 we will extract A. For 5 we will extract this A and C. For 6 we will extract AB. Then for 7 we will extract ABC. So we will find out we can find out the permutations using the bit right? So how to find out the string using the binary number? Let's see how to find out that. Let's see how to find out the string, how to find out the subsequence from this binary number. We have here 0 0 1. We will just select this C. So to do this, what we're going to do, we're going to run simply a for loop. So we can say bit equals to 0, bit less than n. We will see it. N is the length, and bit plus. This is our loop. Inside this loop, what we're gonna do, we're gonna check here. We will have here a loop for I equals to 1, I less than equals to max, I plus, and here we have a string str equals to empty string. Now here what we're gonna do, we're gonna check I and This is a bit manipulation. This is bitwise AND operator. And here what we're gonna do, we're gonna shift one by the bit, one by the bit. And if we saw this result is not equals to 0, that means at this position, at this index, we have set bit. That means we have 1. So here we see that if we apply this formula here for first iteration, or for this binary number, for this binary number, we get here 1. So we will have this 1 left shift bit, we will have a mark something like this. Then if we multiply, we get here this 0 1 0 0 1. This is not equals to 0. That means this position, at this position we have 1. So what we're gonna do, we're gonna extract this character. How we can extract? We can extract simply str equals to this character. So s dot char at then first here in -1 minus bit. We have to find it from the end, from index, for index 0. If we have to if here we have a 1, that means we have to return the characters from the last index. This means the last character. So if we apply this formula, simply we'll get that. And then here we'll just add str whatever we have. So we'll get C. If we have something like this, actually we find out this C, then in the next iteration bit we will have here one left shift bit, we will have something like this. This is kind of a mask. If we apply, we get 0 0 0, so we'll do nothing. Then again we'll shift 1 to the left, we see we have 0. We find out 0 here, 0 0 0, bitwise AND operation in between these two number is 0, so we'll do nothing. The next number 2, 0 0, then 1 0, we'll go through using this loop. Okay, and then if we have a number, binary number, something like this, then first we have 0 0 0 1, here we have 1, so non-zero, this result will be non-zero, so we'll extract C, then we'll shift 1 right here, we'll multiply, we see non-zero, so we'll extract B, so what we'll get, BC, using this formula. Then we'll shift 1 to the left, we see that if we multiply, we get 0 0 0, so we'll do nothing. We'll extract a character using this logic. I hope you get the idea. When you find out all subsequences or the power set, we'll call a sort function that will sort our sequence or our list in lexicographical order. So we don't have to worry about the lexicographical order. Now let's implement our algorithm. First, let's find out the length of our string. So int n equals to s dot length. Let's create this list to store all the subsequences. So list equals to new array list. We can say a power set. Here we can say this is power set. We will have all the, this is power set. We will have all the subsequence in this list. The name of this list is power set. Now let's find out the maximum number. Int max equals to 1 left shift n, 1 left shift n, then we have to subtract 1. We find out the max value. Now let's run a loop for int I equals to 1, I less than equals to max, I plus plus. Right inside here, let's create a string str equals to empty string. Initially our string is empty string. Now let's extract the character from the binary number. If the binary digit correspond to a characters, we'll extract that character if the binary digit is a 1. So int bit equals to 0, bit less than n, bit plus plus. Bit 0 means this is 0th bit from the right, bit 1 means the second bit from the right, and so on. So right inside here, we're gonna check if we saw I AND. This is a bitwise AND operator. This is not logical, this is bitwise AND operator. I AND, here we're going to left shift 1 by the bit to find out the first to find out the first when bit equals to 0, that means the 0th bit from the right or the first bit we can say from the right. So if this condition is evaluated, if this condition is evaluated true, if this condition is evaluated, actually if this condition is evaluated, if this expression is evaluated non-zero value, that means the 0th bit or the first bit from the right are set for the first iteration and so on. So here in that case, str equals to str s dot char at n minus 1 minus bit, to find out the corresponding character. This is a simple formula plus whatever we have in our str variable. When we're done with this loop, what we will do, we will add this str to this power set. So power set dot add str. And when we are done with the loop, what we will do, we will sort it. We will sort our power set. So collections dot sort power set. It will sort in lexicographical order, and at the end we will return our power set. This is our algorithm. You can practice this question on Geeks for Geeks. Now let me explain the time complexity. The time complexity of this algorithm is we have 2 to the power n number of a power set. Okay, so if the time complexity is O of 2 to the power n, and the length of each subsequence for the worst case n. So the time complexity is 2 to the power n plus 2 to the power n times n. This is the time complexity plus to sorting. For sorting, it will take time complexity O of n log O of k log k, where k is the length of the power set. Okay, and the space complexity is O of n times 2 to the power n. O of n times 2 to the power n. The space complexity O of 2 to the power n times n. 2 to the power n number of power set or subsequences, and the length, maximum length is n. This is the time complexity of this algorithm. I hope you have understood this video explanation. Now let's compile and run this code. We see compilation completed. Now let's submit it. Accepted. We have solved this problem successfully. I hope you have understood this video explanation. If you have any question, post your question on the Q&A forum. Thanks for watching this video.